So we will be looking at some important topics which are graph traversal, BFS and DFS. So at first we will be looking at DFS, depth first search, followed by BFS, breadth first search, and differentiate between both of them. So what do we understand by graph? Well, it will be a sort of tree which contains of vertices and edges.
So graph traversal. Well, traversal of a graph means visiting all the vertices and edges of the graph using some specific method. Well, those two methods are DFS and BFS. So let's start with DFS. Well, it means depth for search. Well, it is a kind of search to go deeper into a graph. That is, if we select a vertex, we will only choose one adjacent vertex for one iteration, and we will explore that adjacent vertex. Similarly, in that vertex, we will choose only one adjacent vertex and go on ahead. If that adjacent vertex doesn't have any adjacent vertex, then we will suspend that vertex. Then we will come back to the previous vertex and explore again. We will pop out all the end vertices and we will come to the first vertex. This will stop the first iteration. For second iteration, we will choose the next branch and go on. Here we have an example of DFS in front of us. So we have vertices, namely A, B, C, D, E and F in front of us. So we will choose vertex A and now we will explore the nearby vertex B. Now we will explore vertex B and check for the adjacent vertices. So we see that C is the next vertex. After C we go on to F. We see that F is the last vertex since it comes back to B again. Therefore, F will pop out. I am using the term pop out because we have stack implementation here in DFS, and and now from B we will go to C and then to H, which is another vertex of C. Here it is the last, so pop it out as well. Then come back again to C. Now no one is next to C, so pop it out as well. Come back to B. Now no one is next to B, so again pop it out again. Now come back to A. This completes the first iteration. Now in the second iteration, visit the vertex C, which is the another branch of A. On exploration, we first check C. Since C's nothing is next to E, so pop it out as well. Now come back to A. All the vertices of A are checked, so pop A out now. Now D here is the leftover one, so we will create a different spanning tree. So D is now the first vertex here. So D's vertices here are C, E and G, out of which C and E are already gone. So go to G. G is the last, so pop it out and come back to D. Now D is the only remaining vertex, so pop it out. So the tree which is now created newly in front of us is called DFS spanning tree, and the spotted lines in green, blue and red are called the back edges. And also, not to forget mentioning, the complexity of DFS is of the order of n, which means we have n vertices and we visit all the n vertices, so the order is n and the complexity is n.
So moving on to BFS. So it is basically breadth first search, which is a searching method. Instead of searching deeply, we usually search broadly. That is, BFS tries to search all the paths at the same time. It has the implementation of queue in it. So basically, while solving a BFS graph, we need to remember 2 points: visiting a vertex, exploring each and every branch. So here we goes with an example of a binary tree. Starting with the first vertex, we have number 1. Then we will visit the adjacent branches that we have as a number 2 and number 3. After visiting number 2 and number 3, since they are not the goal nodes, we will then move to 4, 5, 6 and 7 will be explored in that order. Finally, the number 8 or number 8 vertex will remain. So finally we will explore after 7. Application of BFS. BFS usually give us a way to solve the graphs in a shortest path we can, and it is also help in flood filling, which is used in Penn's technique and etc. Here we have the comparison of DFS and BFS.